Hello everyone, I welcome you all to another video of daily Leetcode problem solving. So if you are new to the channel, you can subscribe to the channel. Here I upload daily Leetcode problem video solutions, and that too in in-depth solutions and various different analysis with the approach on the approach. So you can subscribe and can watch all the videos. I have added the link to the playlist as well in the description so that you can check out the other videos, and you can connect with me on the LinkedIn and Facebook. I provide the profile in the description as well. So let us see today's problem. So we have been given a 2D matrix and which is immutable, which means we cannot do anything, we cannot change, we cannot modify the given matrix, right? This is immutable. And to that given 2D matrix, we need to return the range sum. There will be few queries, and each query will demand a range sum, right? So given this 2D matrix, and then given that upper left corner of the matrix described by row 1 column 1 and the lower right corner of this matrix, and to this we need to return the sum which falls. We need to return the sum of that submatrix whose starting row and column is row 1 comma column 1, and the last cell, bottom right cell, is the row 2 comma column 2. What does this mean? If the matrix is something like this, let's say this is the matrix. If let's say this was my row 1 column 1 and this is my row 2 column 2, so I need to return the sum which whose top left element is this and bottom right element is this. So the matrix is this, right? I need to return sum of this matrix, right? This is what I have to do. So let us take the example test case here. Let us see this. So this is the matrix. So if this colored cell represent that submatrix, right? This is the one submatrix. This is the another submatrix in the violet color. This is another submatrix in the red color. If I name the row and columns, see from this is the first row, first column, second column, third and fourth column. This is zeroth row, first row, second row, third row, and the fourth row. So the first submatrix is starting from this index, which is 1 comma 1, and ending at this index, which is 2 comma 2. The second submatrix is starting at this index, this is 1 comma 2, and it is ending at 2 comma 4. And the third submatrix, which is in red color, is starting from 2 comma 1 and ending at 4 comma 3, right? So there are three submatrices. I need to return the sum. So what we can do, a naive approach will be, if I have been given this submatrix, what I will do, I'll start from the first row, which is this one, row 1, and for this row, I'll go through all the columns, right? Starting from the column 1 up till column 2, right? And I'll accumulate the sum. So I've got the sum of the first row. Then I'll go to the next row, and then again starting from column 1 to column 2, I will accumulate the sum, right? I'll accumulate sum up till here, then up till here. And since I'm done with all the rows from row 1 to row 2, right? First row is also done, second row is also done. That means I have calculated the sum of this submatrix, and then I'll return that sum, right? Similarly for each this. So if I do something like this will be a naive approach, and the time complexity to do this is if the matrix has a size of m cross n, right? Then what I am going to do in the worst case, let's say if there are q queries, right? Q queries, and each query, the size of the matrix is, let's say, m into n. In the worst case, we are taking which the size is equal to it is the biggest sum matrix, which is this matrix itself. So to calculate sum for the one query, what the time I'll be taking, I'm basically iterating over the entire uh, that sub matrix. So if the matrix has m into n elements, that means the total time I'll be taking will be order of mn. So for the q queries, the time will be q into m into n, right? And let us see what are the values, what are the given constraints for these values. So mn will be less than or equals to 200, and it says that at most 10 to the 4 calls will be made to the sum region. There will be at most 10 to the 4 queries basically. So if I calculate the value of this, the q will be 10 to the 4 in the worst case, m will be 200, this n will again 200, so this will be 4 into 10 to the power 8, right? This much of computation I will be needing. So this solution, if we try to submit this solution, this might give us TLE. The solution which is computing in the order of where we do computation in the power of 10 to the power 6 generally gets accepted, but I don't think this solution will be accepted. So we need to do something else here. Okay. So let us think something else here. So another approach which we can try here is that, just bear with me. See, what I am doing essentially, if I'm being given, let's say, if I consider this matrix, this purple one, this is the row 1 column 1, right? And this is the row 2 column 2 of this matrix, sub matrix. So what I'm doing in that naive approach, I was going to each row and calculate the entire sum of that row in that sub matrix. Then again I go to the next row and then calculate the entire sum of that sub matrix, right? So we can just we should not do this type of computation. Okay, we can avoid this thing. Why? How? Because we can see that if we do something like prefix sum, so if I have some prefix sum, let's say up till this index, just before this column, right? Just before column this given C1, I have some up till this index. I have some up till this index. Then the sum of the entire row will be, this will be the sum of the entire row, right? And this index will contain the sum up till here, right? So from this entire sum, if I subtract this sum, I'll be getting the sum of these elements, right? What I'm saying, this index will contain some of these elements, right? And this index will contain some of all these elements, right? If I do something like prefix sum, what is a prefix sum? Basically, I'll store the sum at the ith index. If let's say let us consider a 1D array. Let's say 1, 2, 3, 4, 5, right? So the prefix sum will be at this index. There is no other prefix of this. This is the only prefix. So the sum will be 1, right? So what is the prefix of this? The entire this. So the index before this in this array will store the prefix sum before this index, right? So I add this prefix sum to this index, so I'll get the prefix sum up till this index, right? So 2 plus what is the previous prefix sum? It is 3, right? So the prefix sum up to this index is 3. Then I move to the next index. So to get the prefix sum up till this index, I'll add this element to the prefix sum till the previous index. So this will be 6. and then again the prefix sum up till this index is 10, and here it is 15, right? So basically this at this index it stores the sum of if I say prefix sum of I, so this is store sum of 0 up till sum of 0th element a of 0 up till sum of a of I. So this is what prefix sum is, right? So this index will store prefix sum this entire row, and this index will store prefix sum up till this index. So if I subtract this prefix sum from this entire prefix sum, I'll get the prefix sum of these elements, right? And this computation will be order of 1, rather iterating over all the columns. Earlier I was taking the number of columns amount of operations to calculate the sum, but this computation can be done in an order one time. So for the each row, for the first row I'll get the sum, for the next row again I'll get the sum, right? And I'll add all these sums, so that will be the sum of this entire submatrix, right? So let us try to once do try run this thing, and then we will code this thing, right? So we have this matrix, and the size of the matrix is 1 2 3 4 5 rows, 3 4 5 columns, right? So in this new matrix I'll be storing the prefix sum for each row. Okay, so the prefix sum for the first row will calculate prefix sum for this row, right? 0th row. So this will 3, then to this the element at this index add the previous prefix sum before this. So this is 3, and at this index we have 0. So prefix sum up till here is 3. At this index the prefix sum is 1 plus the prefix sum before this index. So this is 4. For this index the prefix sum will be 4 and plus 4 8. For this index previous prefix sum is 8. This element is 2. This is 10. For the first row, prefix sum will be 5, then 6 plus 5, 11, 11 plus 3, this will be 14, 14 plus 2, 16, 1, 17, right? Here 1, then 3, then again 3, then 4, then 9. Here 4, 5, 5, 6, 13. 1, 1, 4, 4, 9. So I have calculated prefix sum for each rows, right? Now let's say I have been given this one, this submatrix. So what is the R1 C1 for this? This is 1 comma 2, right? First row, second column, and the last index is second row, fourth column, right? So this is what we have. So to calculate prefix sum of this index, what I will be doing, since the starting index is 1 comma 2, where is 1 comma 2? First row, second column, this element, right? And where is 2 comma 4? This is 2 comma 4, right? I need to calculate sum of this submatrix. So for the first row, what will be the sum of this submatrix? So I need sum of these elements, right? These elements. So for the entire row, the sum is 17. And what is the sum just before this index? This is 11. So 17 minus 11, this will be 6. So the 6 will be sum of all these three elements, right? Because the entire row has sum 17, and to this index, the sum is 11. So this is the remaining sum. So this is 6. Similarly, for this row, what I need sum of these elements. So for the entire row, the sum is 9, and up till here the sum is 3. So 9 minus 3, this will be 6, right? So I'll add these sum, it will be 12, right? So prefix sum will be 12. So let us see what is the given answer here. So this is the 12, 1, 2, 2, 4. So we have calculated for 1, 2 and 2, 4. Let us do for the another one. Let's say this submatrix, red one. So this is the top left corner, 2 comma 1, and this is the bottom right, 4,3, right? Where is 2,1 here? 2,1 is this index. Where is 4,3? 4,3, 4,3 is this index, right? So I need to calculate sum of this sum matrix, right? So calculate sum of this first row in this sum matrix. So up till this index, the sum is 4, which means the sum of all these 4 elements is 4. And what is the sum before this index? This is 1. So the sum of these 3 elements will be 4 minus 1. This is 3. Similarly, sum of these elements will be 6 minus 4. This is 2. For this row, the sum will be 4 minus 1, which is 3. Add all these, this will be 8, right? 3 plus 2, 5, 5 plus 3 is 8. So let's see what is the answer. This is 8, 2143, 2143, right? So in this way, we can do this. So what is the time complexity I'll be taking if I code this solution? So there will be q queries again, and the size of the, in the worst case, the size could be m into n for each query. So what I'm doing, if the query, if that sub matrix has m number of rows and n number of columns, so now I will be iterating over all these rows, and to get the sum to that row, that is a constant operation. So essentially I'm just taking the time complexity in the order of number of rows only, right? So this will be reduced to q into m. So again, if we calculate the total number of operations, it will be the value of q in the worst case will be 10 raised to the power 4, and the m will go up to 200, right? So this will be 2 into 10 to the power 6. So definitely the solution is going to be accepted, right? So let us first of all code this solution, and we can think something else as well here. We can, I think we can optimize this solution further. So first of all, let us code this solution and then we can see. So I say that to store this prefix sum, I need to create a prefix sum array which will store this prefix sum, which we have done here. So I'll say that I'll make it as private member. Do not focus on this thing. So I'll name this array as DP, right? Because basically I'm to calculate sum of this index. I'm not again and again calculating sum starting from this index. I simply use the previous sum. So this is the kind of dynamic programming. So that's why I just named this array as DP. So the size of DP initially, what the size has to be. So see, to calculate the prefix sum, what I am doing, I am taking this, the element at this index, and what is the prefix sum before this index, right? So if you see, for the 0th index, there is no element before this. So we have to handle this case separately. If I simply do dp of I is equals to prefix sum before this index, which will be dp of I minus 1, plus what is the element at this index? It will be matrix of I, right? If I simply do something like this, so it will work for this, because dp of current dp is I'll be filling dp of 1 and it will refer to dp of 0, right? dp of I minus 1. But when I am here, this will give me an index out of bound. So either I have to I have to handle this case separately. When the case is the index is 0, then do not take the previous prefix sum, just take this element at that index, right? Or I can do one more thing. I can map the original indices to this prefix array to a +1 index. So what I'm saying, that if this original matrix has had already 5 columns, so here this matrix will have 6 columns, right? So this 0th column will be mapped to the first column here, and the first column will be mapped to the second column. This will be third column, this is 4, this is, and this will be 0th column. And in this, the element at this index will be 0 by default, right? So now, since I'll be starting from this position, I map this index to this index. So to fill this index, now I do not need a special case to handle the when I'm at index 0, because at this, in this array, that 0 index has already been mapped to the first index. So in this time, this dp of I will always, because this is the first element, so dp of I will never be 0. Okay, the formula will be little modified. This will be, if I am starting from index equals to 0, so I'll be filling dp of I minus I plus 1, right? Because the index 0 in matrix has been mapped to index I plus 1. So if I'm filling the 0th index, if I'm doing work for the 0th index in matrix, then that work should reflect to the first index in the dp. So this is what I'm doing. So dp of I plus 1 will be simply dp of I previous plus matrix of I, right? Because I'm doing work for the ith element, and the work of the ith element is being stored to the I plus 1th element, right? So this is what I can do. I do not need to write a special case. So I'll create one extra row, right? So let us create this. So the row will be the same, which matrix already has, and the number of columns will be one more than this, right? And for each row, okay, I'll be iterating on each row. Okay, for the initially I'll be doing work for the first row, and in the first row I'll be storing the prefix sum, right? So to calculate the prefix sum, I'll iterate over all the columns. For j equals to 0, j is equals to matrix of 0 dot length and j plus plus. And now to fill the jth column, okay, so initially the row will be exactly, because we have mapped rows exactly which is in the matrix, but we have modified for the columns. So if I'm talking 0th column in matrix, that will be first column in the dp. So this will be j plus 1. So this will be what? dp of I comma j plus matrix of I comma j, right? This is what. And in Java, by default, the array has this int array will have 0 stored at each index. So initially I have not filled these indices in dp. So if I'm writing, I'm first of all, in the very first step, I'm writing this value in the dp. So this will refer to this index, and this index will contain 0 by default in Java. So this is a pre-computation which I've already done. Now what I'm doing, so I'll create a variable sum, and now I need to calculate the sum. So what I was doing, I was iterating over all the rows, and I was calculating the sum of that row in an order one time, right? So for each row, I'll be doing, for starting from the row 1 and go up till row 2, this plus plus, and the sum is going to be dp of, because I'm at the ith row, right? So then in that ith row, take the sum up till column 2, right? So this is essentially what, if I'm at this row, take the sum of this row, ith row, and c2 column. So this is 17, right? And to this subtract dp of, for the same row, column 1 minus 1, right? So if the column was this, then subtract this one, right? And we need to take care another thing, since the column 2 and row 2 are with respect to the original matrix, but we have mapped the indices of original matrix to the dp, and the row were same, but column was one more. If I'm referring column 2 in matrix, then column 2 will be column 2 plus 1 in the dp array. So if I want sum before column 1, so the column 1 will be column 1 plus 1 in the dp. and column 1 minus 1 will be just the column 1, right? And if I want to refer to column 2 in DP, it will be column 2 plus 1, because all these columns have been shifted by 1 in the DP array, right? So, and finally, when I'm done with all the rows, I'll just return the sum. So let us see if it is working. So the sum error, okay. So it should be a 2D array. Okay, it is working. So I think the solution should be accepted. Let us submit the solution. Okay, it is getting accepted. Okay, so let us try to further optimize this solution. Okay, let's start again. So I need your attention. Just bear with me. You will be able to get this concept. Okay. So now what I was doing, I was iterating over each rows. But if let us think even if we can even eliminate that operation as well. If we are going over entire row, if I do something like this, if I need to calculate sums for this sum matrix, so if I build an array which gives me sum, let us see first of all, if this is a sum matrix, okay, and this sum matrix is part of this sum matrix, right? If I do something like this, that to get the sum of this sum matrix, if there is something like that that gives me sum of this sum matrix and sum of this sum matrix, right? So sum of this sum matrix and sum of this sum matrix, and I already have sum of this sum matrix. Then to this sum, if I subtract this sum, total sum, so I will be left with this sum, right? If I do something like that, if I can get the sum of this sum matrix in order one time and the sum of this sum matrix in order one time, then I'll get the sum of this part in order one time. And if I get the sum of this sum matrix in order one time, then I can simply calculate sum of this sum matrix in order one time, right? Just simply subtract this sum of this region from the entire sum of this sum matrix, right? This is what we need to do. So let us see this again. What I'm doing, if I have some array which stores of all the elements before this and before this, basically what I'm saying, if I'm at index I comma j and that I comma j gives me sum of the matrix which starts at 0 comma 0 and the top left corner is 0 comma 0 and the bottom right corner is I comma j. Okay, if I'm looking at I comma j, that matrix should give me sum of all the elements present in this area. So if my I comma j was, let's say, if my I comma j was, let's say this is 2 comma 3, so the matrix should store the sum of this sub matrix, right? So if I have something like this, I will be able to compute the sum easily. Let us see how. Let us see. So I was saying that I already have that something like that. So let's say I want to calculate some of this submatrix. So the top left corner is 2 comma 1 and the bottom right corner is 4 comma 3, right? I need to calculate sum of this. So let us say in that submatrix I'll get the sum of this index. This is 4 comma 3. So what that sum will return? This will return sum of starting from 0 comma 0 and whose top bottom right corner is this. So this that will return sum of this submatrix. This submatrix, right? Then I need to subtract this part first of all. So if I ask what is the sum at what that array will give me, that array which we are talking about. If I say the index 1 comma 3, what will be stored at index 1 comma 3? So at index 1 comma 3, the sum the sum of a submatrix whose top left corner is 0 comma 0 and bottom right corner is 1 comma 3, that sum will be stored at that index, right? So at this index the sum of these elements will be stored, this. And what does dp of 4 comma 0 will store? This is 0 comma 4 comma 0. So this will store a submatrix whose top left corner is this and bottom right corner is this. So this will store the sum of this submatrix, right? This submatrix, right? So we have all these sums, right? If I build that kind of array, so what I will be doing, I'll add this one and this one. So I'll get the sum of this region, the elements who fall in this region. But see, this part is common. This part, I've calculated this sum twice. This was already covered in this submatrix, and this part is again covered by this submatrix. So I need to subtract this sum as well, right? So I'll get the sum of this region, and then to that, I'll get the sum of this whole region. To that, I'll subtract the sum of this region. So I'll get the sum of this region, right? I hope you get it. So how to build such a matrix? Let us see. Okay. So what dp of I is going to store? It is going to store the sum of the matrix submatrix which starts at 0 comma 0 and whose bottom right corner is I comma j, right? If I'm at here, so how to calculate the sum? So the easiest way will be to calculate sum of this index if I can get the sum of a submatrix whose which is just above this, right? Submatrix just above this. If I get sum of this submatrix, and again if I get the sum of submatrix whose column is just before this, so that will be this submatrix. So this will store the sum of this submatrix, right? Again in this array, and this matrix will store sum of this submatrix. So I'll get the sum of this submatrix. I'll get the sum of this submatrix, right? And since this is the common area between all both these submatrices, right? So I need to subtract this submatrix sum. So this will be given by this. This will be stored at this index. So this index will be filled by what? The element at this index, right? And to that, what I'm doing, I will be calculating sum. How? This will give me the sum of this submatrix. So to that, I will be adding First of all, I'll get the sum of this matrix. So this will be dp of I and I minus 1 actually, because a row before this, and to same column sum of this sum matrix. So this will be in the same row but a column before, dp of I comma j minus 1, right? And because this area was covered twicely, so I need to subtract this area. So to get the sum of this sum matrix, this will be stored at dp of I minus 1 and j minus 1. So I need to subtract this thing, right, to calculate this sum. So the formula becomes, to fill up index dp of I comma j, this will be matrix of I comma j equals plus since I'm subtracting, what I'm doing, I'm adding this thing. So dp of I minus 1 comma j plus, so all this basically. So we can create this array. And also one thing, if I was at this index, so again this will be a corner case because there is no row above this and no column above this. If I'm at this index, there is no column before this. If I'm at this index, there is no row before this. So to handle these cases separately, we have to handle these separately. But I can also get rid of this by creating an extra row, an extra column, and map the indices of original matrix to a plus one index. If the row was I, so in this matrix it will be I plus one. If the column is j, so in this matrix the column will be referred as j plus one, right? Just do this. So if I'm talking about 0 comma 0 in this matrix, it will be 1 comma 1 in this matrix. So we do not need to do, we need not to handle this separately. So I'll simply create an array of row plus 1 size and column plus 1 size. And to calculate dp of I, this will be dp of what I'm going to do, dp of I plus 1 and dp of j plus 1 will be what? Matrix of I plus 1. This is already there. dp of I minus 1j, since I minus 1 refers, because index is 1 added, so this will be just I and this will be j minus 1. J minus 1. So let us write in the same manner what we have solved. So this will be dp of I, because I minus 1 will be just an I, and j will be j plus 1. This is 1 added, and this will be written as dp of, because I'm referring to ith index, so in the original matrix I, that in the dp array it will be I plus 1. So dp of I plus 1, and the j minus 1 will be just j here, and to this minus, I'm subtracting I minus 1, j minus 1, so it will be just I comma j, right? So I have already created this dp array. Now what I need to do, so how I was calculating the sum, to calculate sum at this index, I'll get the sum at this index, right, initially. So just see what I'm doing. I will be doing the same thing. What I'm going to return, first of all, take the sum of the last cell, bottom right cell. So this is row 2 column 2. So in the dp array this will be referred as row 2 plus 1, column 2 plus 1, right? And to that I'll subtract the sum of, I was subtracting the sum of this region, right? So to get the sum of this region, this will be what? A row before this one and in the same column. So this was row 1. So this is row 1 minus 1, right? And this is column 1 and this is as well column 1. So I'll get the sum of this sum matrix by dp of row 1 minus 1. I need to get the sum of the sum matrix whose bottom right corner is this. So in the original matrix it was row 1 minus 1, but in the dp matrix it will be just row 1, right? And since in the original matrix, this is column 1, column 2, sorry, column 2. But in this DP matrix, it will be column 2 plus 1, right? And I've got the sum of this region, then I need to get the sum of this region. So this is what? Row 2, right? I need this, and this is column 1, right? Column 1 minus 1, right? So I need to get the sum of this submatrix. So in the original matrix, it is referred as row 2. So in the DP array, it should be referred as row 2 plus 1. And in the original matrix, the column was referred as column 1 minus 1. So in this DP, it should be just column 1, right? And I need to add these things first of all. And that to this, I have already computed this area twicely. So I need to subtract this. So this is what? A row before this. So row 1 minus 1 and a column before this. Column 1 minus 1, right? So it should be in the DP array, it will be just row 1 and just column 1, right? Because one added index, and I need to return this thing just. So let us see if this works. Okay, it is working. Let us submit the solution. So the solution is getting accepted, and there is a little improvement in the runtime. So let us see what is the time complexity. So we are already, since I'm not iterating over anything, I'm just getting this sum in an order one time, and this is just an arithmetic operation is going here. So each query will take order of one time, right? And if there are q queries, I'll just take order of q time here, and it is raised 10 raised to power 4. But in the previous approach, I was taking the time 8 into 10 raised to the power 6, right? So this much, sorry, it was 4 into 10 raised to power 6. So there is 100 times improvement here. I'm doing 100 times less operations now. Okay, and for this I'm creating another DP array, and so that's why I am taking space of order of m plus 1 into n plus 1, which is basically order of m into n space. Okay, so I hope you got the solution. If you still have the doubt, you can mention them in the comments, or you can message me on LinkedIn. I've already provided that in the description here. So see you in the next video. Thanks for watching.